Dual clutch transmissions, or DCTs, have become a popular transmission option for vehicle designers as they combine the gear efficiency of a manual with the shifting ease of an automatic. Here's how they work. Dual clutch transmissions contain the traditional elements of a manual and are driven by a twin or dual clutch module. The manual elements include helical gears on parallel shafts to create different gear ratios, synchronizer systems to ease gear engagement, and an actuated shift fork system to select the appropriate gear ratio. The clutch module can either be dry, like a conventional manual, or of a multi-plate wet clutch variety, like those used for shifting clutches on step-level automatics. This demonstration will show the wet clutch variety. Although a traditional manual transmission uses a singular input shaft, the gears in a dual clutch transmission are driven by one of two input shafts. Typically, the odd-numbered gears are driven by one shaft and the even by the other. Hydraulic fluid pressure is used to actuate the respective clutches as needed. Fluid is used to lubricate and cool the clutch as well. When the driver puts the gear selector in drive, the appropriate shift forks will cause the engagement of first gear. When the driver presses the accelerator pedal, the outer clutch will be engaged to launch the vehicle from rest, driving power through first gear. Much like a manual transmission, the DCT uses synchronizers, which are friction devices that match the input shaft speed to the selected gear speed during a change. The cone of the gear makes contact with the collar before the gear teeth mesh. The friction between the cone and collar brings the two to the same speed prior to teeth engagement. This creates smooth gear changing. As the vehicle accelerates in first gear, the second gear is also engaged by way of the synchronizer system to the inner non-engaged clutch. When it's time for the vehicle to shift into second gear, the outer clutch will disengage and the inner will engage, thus directing the power through second gear. The exchange of power flow from the outer to inner clutch occurs in a few hundredths of a second, which is quicker than the typical shift time of a step-level automatic. As the vehicle accelerates through second gear, the shift fork system will deselect first gear and select third. When conditions are appropriate, the inner clutch will disengage, the outer will re-engage, and the power will then flow through the pre-selected third gear. This back and forth power flow between the outer and inner clutches continues throughout the gear ratios, as the shift fork system continuously anticipates the next needed ratio and pre-selects the appropriate gear. Power now flows through fourth gear. And into fifth. And finally into sixth, as the transmission shown is a 6-speed gearbox. The innovative dual clutch design and precise control that has been demonstrated allow for much quicker gear changes than manual or planetary automatic transmissions. This enables improved performance and fuel economy, which will make dual clutch transmissions a continued option for future drivetrains.